In our last video, we talked about two types of variables. We had quantitative versus categorical. Today, we're going to focus on the quantitative variables and discuss discrete versus continuous a little bit more. Let's get started. Our lesson for today is going to focus on grouped data and why it's important. To begin with, grouped data allows you to create intervals that group data together, obviously. This is useful when you have data with gaps in between them and you want to talk about the different categories for your grouped data or the different ranges for your grouped data. This is useful when you want to compare different portions of your data to itself or possibly to other sets of data. We're going to look at a couple examples that help us identify when grouped data is appropriate for both discrete and continuous data. Alright, so here we have some data that represents test scores for a recent unit test. And you can see that the scores are pretty varied. Looking at them individually might not make a whole lot of sense. So what we're going to do is we're going to group them into appropriate intervals, which will allow us to compare those intervals to the data within itself. Let's look at how we can group them. When setting up our ranges, we're going to make sure that we incorporate all of our scores. So our lowest value is 12, our largest value is 100, and our ranges are going to go from 11 to 100 to incorporate those. The other important thing is that the distance for each one of our ranges is the same. So 11 to 20, 21 to 30, 31 to 40, and so on are all ranges of 10. Now we can calculate our frequency table, which will tell us how many scores were in each range. For scores between 11 and 12, we had 4 scores. We had the 12, 19, 12, and 18. And then we just calculate the rest of the scores as we normally would. And then we get to our relative frequency table, which we're going to use more later in the chapter when we do standard deviation. But for relative frequency, you're going to take the frequency for a specific range and divide it by the total. In this case, there were 30 scores. So now that we have our frequency table, we can use this to set up our column graph. Again, the frequency is going to represent the height of each column, and then on your x-axis, you're going to have your different categories or ranges as your labels. Alright, so here we can see the result of our frequency table being turned into a column graph. Again, the height of each column represents the frequency of that score happening. So again, there were 4 scores between 11 and 20, and so on. Looking at our distribution, there isn't any real normal distribution. It's not symmetrical, it's not left skewed or right skewed, or positively skewed or negatively skewed. So this is just our data and how it looks. We could also use this to answer some more questions. For example, how many people pass the test? Looking at our bar graphs, we now know passing a test would be anything above a 70. So we have 3 columns that we would add to answer that question. I could also ask how many people got an A on the test. So we have our 90 to 100 column. So now that we have our group data, we can talk about the different categories of a test. Passing a test, not passing a test, performing well, maybe improving on a test. But we can use it to answer different questions as opposed to looking at all the individual data. For continuous data, now we're going to be measuring and approximating values instead of getting definite numbers. Some examples of continuous data are height, weight, time, and length. Again, that's because they are all being measured. On a side note, when you graph or when you set up a bar graph for a continuous data experiment, you're going to be creating a histogram. And the difference between a histogram and a column graph is that for a column graph, there's spaces between the columns, whereas for a histogram, they are touching. And they're touching to represent the continuous portion of our data and the fact that we're measuring, we don't have exact values. Let's go ahead and look at an example of grouped continuous data. 20 people were asked last night how much time they spent on homework, and their scores were rounded to the nearest minute. Since it's time, we are again going to use a continuous data because we're measuring the amount of time. And just so we know how we're interpreting this, we have 32 minutes, 43 minutes, 56 minutes, and so on. Again, we want to make sure that when we set up our groups, we have appropriate ranges, starting with our smallest number and going to largest. So we notice our smallest number was 12, the largest number was 56, so our ranges have to incorporate those numbers. Let's go ahead and set up those ranges or categories now. Alright, so when we set up a category, it's again, we want to make sure we incorporate all of our values. So I have 11 to 20 as our first category, going all the way to 51 to 60. Again, it's important to note that the categories all have these same ranges. And then we're going to note how many times somebody spent that much time on their homework. So we had 4 people that spent between 11 and 20, 4 people that spent between 21 and 30 minutes, 6 people that spent between 31 and 40 minutes, and so on. And then again, we convert those to our relative frequencies. To convert it to a relative frequency, divide the individual frequency by the total frequency. So we have 4 over 20 giving us a first fraction, and 4 over 20 for the second, 6 over 20 for the third, and so on. Now we can take this and turn it into a histogram. And again, for your histogram, the columns are all going to be touching. The heights are going to be the frequencies for each one of our categories or each one of our groups. And then afterwards we can answer some more questions. I had a little bit of trouble with Excel and creating my labels, so I don't have them for my x-axis, but we have 11 to 21 as our first column, 21 to 30, 31 to 40, 41 to 50, and 51 to 60. And we can see that we have a slightly more normal distribution. If I were to draw my curve, it would look a little bit like that. The left side is a little higher than the right side, so it's a little more positively skewed than negatively skewed. But now we can answer some questions. For example, on your homework you had a question about what was the modal class, which means what's the mode or the most often occurring. So that would be our middle column, and that is the 31 to 40 minutes. Which means that most of the class spent between 31 and 40 minutes on homework, which is pretty average. We could also ask how many people spent more than the mode, or more than 40 minutes. So adding out your last two columns, we get that 6 people spent more than 40 minutes on their homework. Alright, this does it for our notes on discrete and continuous data. Go ahead and start the homework.